So next we are going to see kappa analysis. So what is kappa analysis definition? Kappa was introduced by Jacob Cohen, a prominent statistician who developed the key statistics for measurement of inter-rater reliability. So what is inter-rater reliability? So as you all know, in the production, uh, so many people will be involved in inspecting. Any, it can be a dimension or it can be a defect. So assume a case, one person agrees that is a okay part and another person agrees it is a not okay part. So therefore, in order to avoid this confusion or to check the inter-rater reliability, we use kappa analysis. So here in the kappa analysis, there will be two people. One will be the master and one will be the rater. So what is master? The master data or the definition of master that will be acceptable from the customer end. So for the master approval or the master data, what the rater is going to tell. So in that context or that concept, we are going to do kappa analysis. Now, this analysis is done to see the degree of agreement between two on any factor. So what is degree of agreement? How much they are going to agree and between two on any factor. So you can take, it can be a dimension and it can be a defect, whether the defect is okay or not, something like that. Now, for example, if master is agreeing that and criteria is okay for 50 parts and the rater is agreeing 40 out of 50 as okay. So in this example, what they're telling is the master is agreeing that 50 parts are okay. That means the defect is okay. The rater is also agreeing only 40 parts. Rater is rejecting 10 parts. So he may have some doubts on that or he has not trained on that, something like that. So 40 is agreeing. Therefore, we can say 90% there is an agreement between two. So this is a concept of kappa analysis. Let us see what is the formula. So kappa example. Observed agreement. It is the agreement between two on both yeses and no. So for example, they made a table like this. This is a rater 1, you can assume it as a master, and this is a rater 2, you can assume it as a rater. Okay. So what they given? Yes, 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 and no, and no. So yes, yes means this 60 parts out of 100, both are agreeing yes, it is okay, okay. That is nothing but yes, yes. And master is telling no, but rater is telling yes. So that is 10 parts. 10 parts he is telling no and yes. Master is telling no and rater is telling yes. So if you come to the second row, master is telling yes, rater is telling no. That is around 15 parts. And master is telling no as well as rater is telling no, that is 15 parts. So now in this case, if you see yes, yes, no, no, this is 60 plus 15, that means 75 parts is the observed agreement, that is both are in agreement. 75 parts out of 100, both are telling the same agreement, that can be yes, yes or no, no. This is called observed agreement. 60 plus 15 is equal to 75. Okay. Now coming to the expected agreement. It is the expected agreement by, in the sense, probable number. It's a probable number that can align to both the rater in yeses and no. So what is expected agreement? This is a value that says both shall have that agreement. It is a probable number. So what is a formula for expected agreement? Row 1 total into column 1 total. So what is row 1 total? This is row 1 total. That means for the master yes and no, they're telling yes as well as no. That is around 70. It is a mixed result. Okay. Then plus column 1 total. So for yes alone, so for yes alone, for yes, yes and yes, no. So this is a mixed result of 75. In this both, in the 75 both agreement are there plus mixed agreement are there. So these two are row 1 total plus column 1 total divided by 100. What is 100? This is nothing but the total sample that sample size that you've taken. In the same way, we are going to add it with the row 2 total. What is row 2 total? Row 2 total is around 30 into column 2 total 25. So why we and divided by 100? Okay, why we are dividing it? Why we are doing this formula is since there is a mixed result and it is distributed both the side. See, when you add this, it comes 100. When you add this, it comes 100. That means in order to extract the expected agreement, we are taking that we are dividing with 100. So when you divide with 100, we will come to know how many times the numerator gets divides. Based on that, we'll get a probable expected agreement because it will be a mixed result. No, see, we don't know maximum data can be here or here or here. Therefore, we take both the things and divide it. So we will get an expected agreement as 70 into 75 divided by 100 plus 30 into 25 divided by 100. We get 52.5 plus 7.5. See, the second one, row to total plus column total, we have very less distribution, only 7.5 is there. So whereas in this case it is more. Which one? Yes side. Row 1 and uh, row 1 and column 1 is more. That means here very less distribution is there, they are telling. Towards no. You got it. No, this is a probable number. Now in the expected agreement we got 60 is the expected agreement by chance based on the distributed value. That means 60 percentage there is a chance we can expect the agreement between two. Okay, so that is an expected agreement. Now we'll see the kappa formula. Now we'll see kappa formula. Kappa value is equal to number of observed agreement. What is observed agreement? The agreement that is what is it? That is an perfectly how much they are going to align. Expected agreement is nothing but predicted agreement. 60% is there is a possibility you're telling. Okay, that divided by total observation, that is 100 minus you're doing number of expected observation. What is number of expected aggregation? The predicted one, you're going to minus it, that number. Now 75 minus 60. 75 is the observed agreement. Based on the 100 sample, you're telling 75 in this sampling, he has agreement is a 75 minus 60. 60 is an what is 60? 60 is an probable number. 60 per 60 that can be in the production it can be 60. They can agree. That divided by 100 minus 60. Okay, what is 100? It is a total observation. You are minusing with 60. Correct. So therefore removing it, you will get 0.375 as a ratio. So what is the meaning of 0.375 is there is an interpretation of kappa value based on the based on the decimal that we get. That means the ratio that we get. If it is between 0 to 0.2, it is a slight agreement. So if it is less than 0, less than chance, there is no agreement at all. If it is 0.21 to 0.40, fairly there is an agreement. 0.41 to 0.61, moderate agreement. 61 to 80, substantial agreement. It's very good. 0.81 to 0.99, almost perfect agreement. So it's nothing but the percentage are given a ratio on which for each this they are given a definition. Now ours is 0.375. So it lies between 0.21 to 0.40. Then we can say both are in a moderate agreement. Sorry, they are a fairly agreement. Still there is a improvement needed. So one thing is to observe here is the drawback of kappa is, say example, the master, this is a master, right? This is a master. Master says yes, and the rater is also telling yes. It is 60, that is okay. This condition is okay. Master is telling that is a not okay part, but rater is telling it is an okay part. That is 10. So this is a not okay condition. Master is telling okay part, and rater is telling is a not okay part. This is okay. Parts can reject, but it will not go to customer. Master is telling not okay part, and he is also telling not okay part. That is okay. So all the three conditions are okay. So here, what is the risk thing is that towards customer point is master is telling not okay, but rater is telling okay. Even this comes one. Suppose one part is there, only one they are not agreeing, and 99 parts, yes is there. This is 0. This is 0. Example. Okay, that means we have to take mixed result. That is fine. But if it is one also, the kappa value can show it is more than 0.3. But this is a drawback of kappa. Okay, so we need to identify a formula. If master is telling not okay, and if the rater is telling okay, then that should be rejected. That should come a different value. So this is just for analysis they invented. That is fine. We can use it. But we need to keep this in mind. When master is telling not okay and rater is telling okay, even if it is a one part, that is rejected. That is not acceptable. Because one part if it go to customer is a problem, right? So that is about kappa. Next we'll see about correlation.